All right, so in this video, we are going to talk through addition and subtraction of fractions. And I want to start at this point because this is what our fifth graders should be bringing with them to fifth grade, because this is the fourth grade knowledge they should have of adding and subtracting fractions. In fourth grade, our fourth grade style problems are like this. They have denominators, which we can notice are the same. So here are the directions that we've discussed in class. And if your student is unfamiliar with adding and subtracting fractions with the same denominator, pause the video, read through these steps, because this is the way that we've discussed it in class. When I look at fractions that have the same denominator, it is like I'm looking at wholes that have been broken up in the same way, because the denominator tells me how many parts my whole is broken into. So 1/4, the whole is broken into 4 parts. And I have 1 of those parts. When I look at 2/4, my whole is broken into 4 parts, and I have 2 of those parts. When I combine to create the sum, of course, I have my 2/4 from my second add-in and my 1/4 from my first add-in, and I can clearly see that the answer is 4 on the bottom, because my whole is still broken into 4 parts, and my numerator is 3. I have 3 of those parts. So when we add with our fourth grade style fraction problems, our denominators are the same. We simply add the numerator. We can see it conceptually here, but certainly we understand it from that repeat practice that we had in fourth grade. In fifth grade, our problems change. And in fifth grade, we are faced with fractions that do not have the same denominator. These are the directions that we've talked through in class, outlining adding and subtracting fractions with different denominators. So students, parents, if you're wanting to review this skill, pause this video and remind yourself of the steps that we've talked about in class. If you're ready to try out an example, take a look at this problem. This is a fourth grade style fraction problem, addition of fractions problem. Let me zoom in to make it more clear. And if I were to break it into a representation, obviously I see that my whole is broken into 5 parts, and I have 4 of those parts. This whole is broken into 3 parts, and I have 1 of those parts. I'm not comparing wholes that are broken into the same parts. I can no longer just add the numerators because I'm not comparing equal values with the numerators and denominators. So the process that we've talked about in fifth grade and that I want to outline in this video is creating equivalent fractions. To do that, the first thing is I take a look at my fractions and I'm going to stack them. Just like I stack my whole numbers and my decimals when I add, I'm going to stack my fractions. When I stack my fractions, I remind myself that those denominators are not the same. I'm going to need to turn this into a fourth grade style question. I'm going to need to turn this into a problem where the denominators are the same. I will do that by setting up my problem as we've practiced in class so that I can create equivalent fractions that have a like denominator. I set this up. This is the structure that I use to help me get to those equivalent fractions. I'm going to zero in on my denominators that are different. I have 5 and I have 3. The first thing that I will do is I want to find the LCM of 5 and 3. LCM means least common multiple. I could sit and just list multiples of 3 and list multiples of 5 and see what they have in common. Or in class, we've discussed an efficient strategy is just to start with the bigger number. The bigger number here, of course, is 5. And I can skip count by 5 until I meet a number that I know is also a multiple of 3. Well, sure enough, I know that 3 times 5 gives me 15. 15 is the first number that they share as a multiple. Therefore, 15 is my LCM. Now, my LCM will become my LCD, because I will use this as my denominator. So 15 will get plugged into the denominator position. And just like in fourth grade, I know if I have like denominators, I can carry that denominator down into my sum. Now, I need to take 4/5, and I need to create an equivalent fraction where 4/5 equals a fraction of equal value, but with a denominator of 15. So I'm going to think about the missing factor here. 5 times what would give me 15? I know that 5 times 3 would give me 15. And whatever I do to the bottom, I'm also going to do to the top. So 4 times 3 gives me 12. I have created equivalent fractions. 4/5 equals 12/15. I'm going to come down and use the same process on 1/3. When I take a look at this 3 times what equals 15? What's my missing factor? Well, 5 makes that a true statement. Whatever I do to the bottom, I'm going to do to the top. 1 times 5 equals 5. I can clearly see that my denominator is the same, so it's simply brought down into the answer. And now, just like those fourth grade style questions, I can simply add my numerators, since my denominators are the same. 12 plus 5 gives me 17. 17/15. That is a correct answer, but it's not in the best form. I'm going to simplify that, as 17/15 is an improper fraction. The numerator is larger than the denominator, so I know that it's larger than 1. I can simplify that by turning it into a division problem. 17 is going to fall inside the box. 15 is going to slide to the side. And I ask myself, how many times can 15 go into 17? Well, it can go in 1 time. 1 times 15 gives me 15. There's a remainder of 2. That 2, the remainder, the bottom of the problem, is going to rise to the very top, and my denominator stays the same. So that is still 15. I know that this equals this. 17/15 equals 1 and 2/15. Now I have the answer in the best form. So in this example of adding fractions with an unlike denominator, the key was to create those equivalent fractions by locating the LCM of my two denominator numbers, creating equivalent fractions, and then carrying out the operation on top.